Sir, am I audible?
Yes, you are audible. Well, let me start basic
Yes, sir.
introducing yourself.
Yes, sir. Sir, I am SubodhCheM Jana. I am from Purbo Medinipur district of West Bengal. I completed my class 10th and 12th from Nachinda Jivan Krishna High School. After that, I completed my BSc from Midnapur College Autonomous. Then I completed my MSc from IIT Guwahati. And sir, currently I am preparing for competitive exams related to chemistry.
Yes, good. Last day we have discussed electrochemistry. Yes, which topic last one?
Yes. Sir, just application of electrochemistry was discussed only.
Only basic.
Kinetics was covered fully. Kinetics was covered fully and electrochemistry was just started. One question was asked the application.
Yes, next is what the oxidation state and reduction. What the difference between oxidation and reduction in electrochemistry?
Yes, sir. Oxidation state in electrochemistry is a parameter that is given to determine the a process whether it is oxidation or reduction. So a arbitrary number is given to the and there is a rule for determining the oxidation state. If oxidation state increases, then it is called oxidation. If oxidation state reduced, then it is called reduction. And the main difference between oxidation and reduction is that in oxidation there is a transfer of electron, that is the loss of electron takes place, that is called oxidation reaction. And if there is a gain of electron for a reaction, then it is called reduction reaction. And it can also be explained in terms of oxidation state also. If the oxidation state in a reaction that is increased for a particular species, then it is called that the species has gone under oxidation. And if the oxidation state is reduced for a species, then it is called that the species that has gone in reduction.
First is basic point is what is electrode in electrochemistry.
Yes, sir.
Now, how many type of
Yes, sir. Yes, sir. Electrode in electrochemistry, it is a part of a cell in which the oxidation or reduction takes place. It is called electrode, and electrodes are of two types. One is anode and one is cathode. Anode, the electrode that, and in case of anode, the oxidation takes place in the particular electrode, and in cathode reduction takes place in the particular electrode. So the electrodes are of two types, cathode and anode.
Next one is what the main application of electrochemical series in electro.
Yes, sir. Electrochemical series, it is a series that is determined by their electrode potential. Generally reduction potential is considered. So this is and they are arranged in the order of their electrode potential E0 reduction value, that is called electrochemical series. And the electrochemical series has a lot of applications. By knowing the position of a particular redox couple in a electrochemical series, we can determine whether it will oxidize or reduce a certain species. If the E0 value it is positive, then it will undergo reduction, and the E0 is negative, then that will undergo oxidation with when it is connected to a hydrogen electrode. And we also can deduce that if there is a possibility of displacement reaction, we can easily state from the electrochemical series if the displacement will take place or not. Also, the some metals can displace hydrogen from the acids, and also some metals cannot do the particular reaction. So in the electrochemical series, we can predict whether the metal will displace hydrogen from the acid or water or not. So it also can be explained. We can calculate the E0 cell, that is the reduction potential of the particular cell, by knowing the electrode potential of the two electrodes, that is cathode and anode. So these types of application can be done. Also, we can get a idea about the oxidation power and reducing power of a particular species present in electrochemical series.
Yes, what's the difference between electrochemical series, spectrochemical series, Irwin Williams series? What the difference?
Yes, sir. electrochemical series. In this electrochemical series, the redox couple that are arranged in the order of their E0 rate value, that is their reduction potential value, and it is mainly used to determine the reduction potential of a particular cell, and also we can predict oxidation, possibility of oxidation, reduction, or displacement of hydrogen. We can explain from the electrochemical series. In case of spectrochemical series, it is the series of ligands, that is the power of ligands. It is expressed in the particular series. If in a spectrochemical series, if it is in first position, then it will be a strong field ligand, and it will increase the crystal field for a particular complex. And if it is in the last position, then it will not be able to split the d orbitals in a large extent. And the Irving Williams series, it is actually a stability series. It actually explains the stability of a particular divalent metal ion for a particular chelating ligands. So these are main differences.
Yes, good. And here
Yes,
is why is electropotential value is zero in hydrogen in electrochemical
yes,
series?
sir.
What the reason?
Yes, sir. Yes, sir. It is actually arbitrarily given that the E0 reduction value for a hydrogen series hydrogen couple is zero, because we cannot calculate the absolute value of the E0 absolute value of the E0 for a particular species. So we have to first standardize a particular species, that we can assign it a zero, and then with respect to the particular electrode we can determine the reduction potential of different types of redox couples. So it is arbitrarily given zero.
What are the conditions in zero present in E0 value is zero? Yes. How many
Yes, sir.
conditions?
Yes, sir. If the concentration of the each species present, if the all the concentrations are one, or the ratio of the concentrations become one, then the electrode potential will have a zero value. And if it is a concentration cell, then E0 cell might be zero. And also if there is only case of hydrogen, it is already arbitrarily given as zero. But so basically for concentration cell and hydrogen electrode, it is given as zero.
Yes. What the difference between electrode
Yes,
potential, standard electrode potential, hydrogen electrode potential? What are the differences?
yes, sir. Yes, sir. Standard hydrogen potential is the potential of a particular electrode when the all the concentration of the particular species is all the concentration of the species are unity. That is, the ln term becomes zero, so E becomes E0. So that is called the standard electrode potential. It is at a particular pressure, and temperature is also given, so it is E0. But the electrode potential E, it is dependent on the temperature, pressure, and the concentration species. So if there is a different types of species is present with their different concentrations, then the total cell potential or total electrode potential, it is given as E, that is the electrode potential. And sir, and the another things was third term,
Electrode
standard hydrogen
potential,
potential.
standard electrode potential, and hydrogen electrode potential.
Yes, sir. And hydrogen electrode potential, it does not depend on the concentration, because it is arbitrarily given as zero. So the standard hydrogen potential and the hydrogen potential for the hydrogen electrode, that will be zero. It is assigned as zero.
Yes, good.
Yes, sir.
Next one is galvanic cell. What is galvanic cell?
Yes,
And how many type of galvanic cell?
yes, sir. Galvanic cell are those cells in which the a spontaneous chemical reaction takes place, and the chemical energy is converted to the electrical energy. That types of cell are called galvanic cells, and galvanic cells are of different types. These are concentration cells, or these can be electrode concentration cell. These can be electrolyte concentration cell. Also, there are different types of cells are also there. Or someone has a salt bridge connected to each other, and someone is not salt bridge connected. So the diffusion takes place via pores. Though the now where the salt bridge is there, it is called cell without transference, and when there is a not a salt bridge is present, it is called cell with transference. So these types of cells are there. Galvanic cells are there.
Galvanic cell and Daniel cell.
Yes, sir.
Yes, galvanic cell used in anode and cathode. This type of metal used in anode and cathode.
Sir, copper and zinc is used. Zinc is used in the anode portion, and copper is used as cathode.
Anode and cathode. Yes. What is salt
Yes, sir.
bridge? Which type of salt bridge used in Daniel cell? Yeah, galvanic cell.
Yes, sir. A salt bridge, it is actually given to maintain the electroneutrality of the particular cathode and anodes. In salt bridge, some electrolytes are assigned where the velocities of the cation and anion must be same to maintain the electroneutrality principle. So generally, ammonium nitrate or potassium nitrate, these types of salts are given in the agar-agar gel to the diffuser, so that the diffusion becomes same in the both the electrodes. So salt bridge, it is connected to the electrodes, and it maintains the electroneutrality of the particular two cells, and continue the cell reaction continues.
Yes, what the function of salt bridge?
Yes, sir. Sir, when no salt bridge is connected, then if some spontaneous reaction takes place, then there will be a net charge in the cathode and anode. So after the formation of the extra potential, so the spontaneous cell reaction will be stopped to prohibit the particular effect. We use salt bridge so that the electroneutrality remains same, and the both the cell becomes neutral, and the reaction carries on. So we generally use the some salts like potassium nitrate or ammonium nitrate, where the velocities of cation and anion are nearly the same, that are used in the agar-agar gel form and connected to the salt bridge. So where there is a net positive charge, the anion comes there, so nitrate comes there, and where there is a negative charge, cation comes there to neutralize the charge, and to continue the cell reaction. So potassium plus comes to the negative charge and to neutralize it, and the cell reaction continues, and we get the electrical energy from the spontaneous chemical reactions.
Yes, what is a half cell reaction in
Yes, sir.
galvanic cell?
Yes, sir. Half cell reactions. This is the cell reaction. If there is if there is a cell, then there will be two electrodes. One is called anode and one is called cathode. So there, combining the two electrodes, there will be a cell. So the cell reaction in a particular electrode, it's called half cell reaction, because this is a half part of a cell. So will be a cathode half cell reaction and anode half cell reaction, and if we add the two reaction, we get the complete cell reaction.
Yes, good. How many
Yes, sir.
type of galvanic cell?
Sir, galvanic cells are cells with transference and cell without transference, and also there is a concentration cell, and there is a chemical cell. So these are the types of cells.
Galvanic cell is three types: primary, secondary, and fuel cell. Primary cell is
Oh,
can
these
be
types.
rechargeable. The secondary cell
Yes,
is
sir. Yes,
can
sir.
be recharged, or and
Yes, sir. Yes, sir.
fuel cell is continuous source of the current.
Yes, sir. Yes, sir.
Primary example is dry cell, zinc mercury
Yes, sir.
cell. Yes.
It's a
Second
Lakeland cell.
example is lead storage battery, nickel cadmium. Fuel cell
Yes,
example
sir. Yes,
is
sir.
H2O2 cell.
Yes, sir. Yes, sir.
So do you have any idea about this?
Yes, sir. Sir, the primary batteries, these are the cells which are not rechargeable. If once it is used, the spontaneous cell reaction is done, then we cannot reuse the particular cell and we have to put a new cell with the place of the cell. So a dry cell is an example of primary battery. And for the secondary battery, it can be recharged. So lead accumulator cell, it is one example of a secondary cell. It can be recharged, so when it is discharged, there will be a spontaneous chemical reaction, and due to the spontaneous chemical reaction, we will get the electrical energy from the chemical energy. And when all the cell reaction is spontaneous cell reaction is done, then there will be no electrode potential in the two cells, two electrodes. So we have to recharge it using a higher voltage battery or a current, and the recharge can be done, so the reaction at the two electrodes, that will be reversed to form the so a non-spontaneous cell reaction will be there, and then again it can be used for the our daily life purposes. These are called secondary battery and secondary cells. And one is fuel cell. In case of fuel cell, it hydrogen and oxygen that are reacted in presence of potassium hydroxide. And in case of fuel cells, the spontaneous reaction of hydrogen and oxygen that is used to give us the chemical give us the electrical energy. So this is the example of fuel cell.
Yes, good.
Yes, sir.
Next one is what's your opinion about the sodium potassium batteries, sodium lithium batteries, sodium ion batteries?
Sir, these are the most advanced batteries. Nowadays, the lithium-ion batteries are used in the several electronic devices like mobiles, laptops, and other things. And this can be easily recharged, and the size of the cell is also very small. So it is compatible with the electronic devices, and this is very useful for the for our daily life purposes. And but there one problem is that if it is not disposed correctly, then there will be the toxicity of lithium. The lithium will be mixed and contaminated with the waters and other important things also. So water pollution can be there. So we have to reuse the battery, recycle the battery. And also we do not make the battery in the garbage to and we have to just reuse the battery. And if there is the battery is damaged, then we have to dispose it, which is given in the particular packet. We have to maintain the particular process to dispose the battery. So this is very much useful, but we also have to careful about the uses of the batteries.
Yes.
Yes, sir.
What are the biggest problem with lithium ion batteries and sodium ion batteries in our society and human being?
Sir, these are the very important batteries, but the main problem is that the sodium and lithium metal that are highly reactive. So if there is a some accident using for the in the batteries, so there will be a burst will occur. So if someone wants to extinguish the fire by water, then there will be a very highly explosive chemical reaction will take place, and there will be some damages. So we have to so the companies and the people should be aware that they are the problem of using the particular high energetic batteries, and we have to use it very much carefully.
Yes, good.
Yes, sir.
Next one is concentration cell. What is concentration cell? How many type of concentration cell?
Yes, sir. Concentration cells are those cells in which there is a spontaneous chemical change that occurs from the high concentration region to the low concentration region. So these types of cells which gives the electrical energy by dilution process, this is called concentration cells. And the concentration cells are two types: one is electrode concentration cell and another one is electrolyte concentration cell. In case of electrode concentration cell, then the two electrodes are used that have a difference in their concentration. So generally the amalgam form of the different metals are used for this particular purpose, and one have a higher concentration and one have a lower concentration. So the spontaneous changes takes place from the dilution process, that is the higher concentration species that is converted to the lower concentration species, and due to this transformation the chemical energy that is converted into the electrical energy. And these types of cells are called electrode concentration cell. And another one types of cells is there where there is a electrolyte that is used in two different concentrated forms. There is two different concentration in two electrodes. So the concentrated species that is diluted in the process, and due to this dilution process we get the potential in the two electrodes. These are called electrolyte concentration cells. So this is the two types of concentration cells.
Yes, what the uses of Nast equation for concentration cell?
Yes, sir. If we use the Nernst equation, then we can calculate the electrode potential of the cell potential of a particular concentration cell. But in this case, the E0 cell will be zero as the two chemical species are same, because no chemical reaction takes place, only the dilution process is going on. So as the two electrodes or electrolytes are made of same material, so E0 cell will be zero, and there will be only form of concentrations which are in the logarithm part. And there will be, if there is a A1 concentration that is converted to A2, then their equation will be E0 is equals to minus 0.059 by n, a log of concentration of A2 by concentration of A1. And if we take the minus term inside, then there will be log of 0.059 by n log of A1 by A2 will be there.
Yes, good. Next one is galvanic cell and electrolytic cell. Yes,
Yes,
why
sir.
is a galvanic cell is del G is always negative and electrolytic cell del G is always positive? What the reason? What
Yes,
the
sir.
condition?
Yes, sir. In the galvanic cell, that is electrochemical cell, in the electrochemical cell or galvanic cell, the spontaneous reaction takes place, and due to the spontaneous reaction, the chemical energy that is converted to the usable electrical energy. So, as the reaction is spontaneous in the electrochemical cell or galvanic cell, so it is the del G0 value that will be negative in case of the particular cells. But in case of electrolytic cell, there is a non-spontaneous reaction going on due to the presence of higher voltage, higher external voltage. So there is a non-spontaneous reaction is going on, and in this process, the chemical energy the electrical energy that is converted to the chemical energy. So in the particular process, there is a non-spontaneous reaction taking place. So the del G0 will be positive for the particular electrolytic cell.
Yes, good. Next one is Nast equation. Yes, what the main application of Nast equation in electrochemistry? Describe.
Yes, sir. Yes, a Nernst equation, it is the most important equation in case of the whole electrochemistry, because using the Nernst equation we can calculate the tendency of the particular cell reaction or the electrode reactions. We can calculate by using Nernst equation. The Nernst equation is applicable for both the cell and the electrodes also. We can use the Nernst equation if there is a reaction is A plus B to C plus D, then the Nernst equation will be E is equals to E0 minus RT by NF ln, and concentration of C into concentration of D by concentration of A into concentration of B. And if we take the reaction in 298 Kelvin, then we can get the equation in the form of E equals to E0 minus 0.059 by N log of concentration of product by concentration of reactants, and the N is the number of electron change in the particular process. So using the Nernst equation, we can calculate the E0 for the particular process, cell or electrode. Also, using the E0, it has a relation with the del G0, because del G0 is equals to minus NF E0. So we can calculate the Gibbs free energy, and knowing the Gibbs free energy, whether it is negative or positive, we can conclude that the reaction will be spontaneous or non-spontaneous in the particular cell. Also, we can calculate the equilibrium constant of a particular reaction, because del G is connected to the minus RTL and K equilibrium also. So equilibrium constant also can be calculated if we know the E0 value. So these are the most important applications of the Nernst equation.
Yes, good. Next is how to
Yes, sir.
determine the solubility product, pH, and equilibrium constant from Nernst equation.
Yes, sir. If we want to calculate the solubility product, then we have to consider the two cells. One is a silver chloride cell, and that is a second kind of electrodes, and it will be connected to the another silver to silver plus electrode. And if we connect the electrode, then if we calculate the equilibrium constant using the Nernst equation, we can connect the minus NFE0 to the minus RTL and K equilibrium. Then we can establish a relationship between the K equilibrium and E0 cell, and we can calculate from the Nernst equation. And also the K equilibrium is if the reaction it is in the form of AgCl to Ag plus to Cl minus, then the K equilibrium will be Ksp. And if there is a the reverse reaction, that is Ag plus Cl minus to AgCl, then there will be the K equilibrium will be 1 by Ksp. So by knowing the E0 or the K equilibrium, we can calculate the Ksp, that is the solubility product of a particular electrolyte, that can be calculated from the E0 data. And also, if we want to know the pH, then there will be a certain reaction which contains the pH term. If we consider a oxidizing agent in the acidic medium, then there will be a term of pH, because it will be dependent on the concentration of H plus. So pH will be term will be there, and using knowing the E0 value, we can calculate the pH of the particular solution.
Yes, good. Any drawback limitation of Nernst equation?
Sir, Nernst equation, it is applicable for all the whole electrochemistry. So, sir, I don't think there is any drawback of Nernst equation.
Yes, good.
Yes, sir.
Equilibrium, yes.
Yes.
Next topic is electrolysis. What is electrolysis?
Yes, sir. Yes, sir. Electrolysis, it is a process where a non-spontaneous reaction takes place by the external electric field or using the external potential. So, in this process, the electrical energy that is converted to the chemical energy, and a non-spontaneous reaction takes place. And so, these types of process is called electrolysis. And in electrolysis, the constituent elements that forms their molecules from from a particular compound, and using the electrolysis, we can extract different types of metals and other elements. Also, the electrolysis of water gives oxygen and hydrogen, so it is very important process in the whole chemistry.
Yes, electrolysis is two law involved. Faraday first law, second law.
Yes, sir.
Yes, carry on.
Yes, sir. In the first law of Faraday, it states that if there is a the electricity is passed in the particular solution, then there will be if 1 Faraday electricity is passed from the chemical species, then there will be the deposition of one equivalent of the particular species, or the gas evolved will be one equivalent of the particular species will be there. And the second law that states that if there is a electricity is passed, then in the two different electrodes, yeah, cathodes and anodes, there will be deposition or liberation of compounds with their equivalent weight, with respect to their equivalent weight.
What is redox indicator? And first of all, what is
Yes, sir.
indicator and how many type of indicator in electrochemistry?
Yes, sir. Indicators are those chemical substances that gives us the idea about whether there is a completion of the reaction. That is, it is used for determination of the end point. These types of chemical species are called indicators. It generally changes its color when there is a end point or equivalence point. These are called indicators. And indicators are of different types depending upon the nature of the titration. Indicators are four types. One is acid base indicator, one is redox indicator, one is complexometric indicator, that is chelating indicator, and one of the last one is the gravimetric indicators. And on the basis of their addition time, the indicators are of different types. The four types: one is self indicator, one is true indicator, that is called external indicator, and one is called spot test indicator, and there is some in case of different types of species, there is some specific indicator. So these types of indicators are there.
What the example of redox indicator? Example.
Yes, sir. There are different types of redox indicator. One is diphenylamine, and another one is ferroin. These types of indicators are used in case of redox reaction.
Yes, 110 phenolphthalein. Yes.
Yes, sir. That is, yes, sir.
Next one is corrosion. What the main application of corrosion in electrochemistry?
Yes, sir. The corrosion, it is a process where the metal is spontaneously makes reaction with the oxygen and with their different chemical species present in the environment, and it forms different types of compounds, and so the metal becomes brittle and it actually corrodes in the whole process. This is called corrosion of different types of metals, and it is generally the oxidation of the metal in presence of air and moisture. So this is called corrosion. And the main application is that in case of corrosion, it actually produces some difficulties towards the human being, because if metal spontaneously corrodes, then there will be the less stability or durability of a metal. If there is a metal pipe which carries the water or natural gas or different things, if the metal corrodes, then there will be the leakage of the particular chemical, and so there will be loss in the whole industry. So they generally uses the different types of reactive materials, they coupled with the particular metal, and so the second metal that is more reactive, so the second metal is oxidizes easily in the whole process. So it basically saves our most precious and the main metal. This is called sacrificial anode. So actually the corrosion, it don't have any particular application. It is actually a problematic thing for the human being.
Yes. How to protect any metal from corrosion?
Yes, sir. There is a process which is called sacrificial anode. In case of sacrificial anode, there is a highly reactive metal that is connected to our desired metal, and so that the highly reactive metal that is oxidizes very readily compared to the main metal or the precious metal, so that it actually corrodes and it saves the main metal from the corrosion. It is generally used for the pipes, water or oil carrying pipes in underground. It is generally used. So this is called sacrificial anode or cathodic preservation.
Yes, good.
Yes.
Next, what the formula of iron rust?
Yes, sir. The iron rust, it is actually ferric oxide. It is actually ferric oxide with different types of crystal molecules, crystal water molecules are there. So it is basically Fe2O3 and XH2O. X can be any number.
Next one is cell potential.
Yes, sir. The cell potential, it is the reduction potential that is for the particular whole cell. This is called cell potential. This is the sum of the two electrode potential in a cell. So this is called cell potential.
Is what the formula of cell potential?
The cell potential E cell that is equals to E cathode minus E anode or E right minus E left if the both the electrode potential are given in the redox form in the reduction form.
Next one is calomel electrode. What is the main application calomel electrode?
Yes, sir. The calomel electrode, it is generally used for determining the reduction potential of different types of electrode. It is called one secondary reference electrode because the calomel, E0 share of the E0 electrode of the calomel electrode, it is determined from the hydrogen electrode. And after knowing the electrode potential of the calomel electrode, it is used for the determination of electrode potential for different types of electrodes, other different types of other electrodes. So it is actually a it is actually a secondary reference electrode.
Yes, good. Last two question from my side. What the
Yes,
beneficial point of whole electrochemistry?
yes, sir. The electrochemistry, it is the whole study of the electrochemistry. It can give us the different types of benefit. That is, you knowing the electrochemistry, we can predict the possibility of the displacement of hydrogen in case of different type by the different types of metal for acids and water. We can explain that. We can calculate the equilibrium constant, or we can calculate the solubility product. We can calculate the degree of dissociation. We can calculate the dissociation constant. We can calculate the hydrolysis constant for a particular species by the conductance or measurement or electrode potential. We can carry out the conductometric titration. We can carry out the potentiometric titration, and we can calculate by this titration we can calculate the amount of the analyte present in a particular species. And also if we know the if we know the Nernst equation, we can calculate the potential of a particular cell made by the different types of chemical species. So that can be known from the study of the electrochemistry. So basically electrochemistry gives us the main idea about the cell potential and particular conversion of chemical energy to electrical energy and electrical energy to chemical energy. And also we can determine different types of chemical parameters from the conductance and electrochemistry measurement.
Yes, what the drawback limitation of whole electrochemistry? Any 5-10 point?
Yes, sir. The electrochemistry that does not deal with the speed of the reaction. So a reaction is fast or slow, it cannot be predicted from the E0 value. It actually gives idea only about the potential, only about the potential of the particular reaction or electrode. It can gives the only idea. And also, if a reaction will takes place or reaction will take place or not, that cannot be all the reaction that cannot be predicted from the electrochemistry. And if there is no redox reaction, then electrochemistry is failed to explain the particular reaction, because it only deals with the redox reaction electrochemistry. And also there are some different terms when there is a, yeah, there some of the things are electrolyzed, then we do not get the expected product every time, so that cannot be explained.
Yes, good. Good. Very nice work from
Yes,
your
sir.
side. Next day we will discuss the left part of physical. Yes, no?
Yes, sir.
Chemical equilibrium, ionic equilibrium, photochemistry. Yes,
Yes, sir.
last other one is quantum.
Yes, sir.